All right, ladies and gentlemen, this is going to be the most difficult assignment we've had in a while, so bear with me. So these are square roots. I'm going to put this, I'm going to simplify them both. So 25x to the fourth over 15x to the fourth, and we're going to try and simplify this. Reduce it down in the lowest terms we can possibly get. X to the fourths go away. 25 and 15 both divisible by 5, so I end up with a big root, 5 over 3. Now, this is the same thing as having root 5 over root 3. We can't have a root down here. So since they're square roots, we can do this. Just multiply by root 3 over root 3. We end up with the square root of 15 over the square root of 9, which is 3. That's it. So number 1 in the books, done. Now, similar story on number 2. We're going to turn this into one big root. 3a to the third all over 6a to the third. So the a to the thirds go away. 3 and 6 are both divisible by 3. So I get that. So then the square root of 1 over the square root of 2, can't have it. We have to multiply by the denominator over itself, since it's just a square root. So up top, I get the square root of 2. On bottom, I get the square root of 4, which is 2. That's your answer to number 2. All right, so 1 and 2 in the books. No problem with the variables because they've all gone away so far. That's all about the change a little bit. So here's what we have. I'm going to go ahead and turn these into one big root. 5x squared over 2x. Now in this case, only one of the x's goes away. So what we're left with is root 5x over root 2. So once again, I'm going to multiply this by root 2 over root 2 to rationalize it. Get that denominator did not have a root in it. Up top, I have the square root of 10x. And then this is all over the square root of 4, which is 2. So then number 3 is done in the books for you. Same thing here. I'm going to go ahead. Yeah, I'm not going to do anything crazy right now. I take the square root of 4. That'd be silly. But I'm going to turn them into one big root. So 4n to the fourth all over 3n squared. Now, it's kind of a fun problem, if you will, but we'll get there in a second. So the n squareds go away, and that turns into n squared up top. So then this is going to be the square root of 4n squared up top all over the square root of 3. So, yeah, what I'm going to do is I'm going to go ahead and just rewrite this. You know what the square root of 4 is? It's 2. The square root of n squared is n. Makes it look a little nicer because now all we have to do is multiply by root 3 over root 3. And my final simplified radical here is 2n root 3 all over 3. And that's that. All right, now, number 5. Let me scroll down just a hair here. Oh, that's too far. Number 5. I'm going to turn this into one big root and simplify it. So I have 4x to the third over 12x to the fourth. I'm going to simplify it. The numbers, the coefficients are both divisible by 4. So I end up with 1 there and a 3 there. Then all 3 x's up top go away, and that leaves us just with an x down here. Now this is our first variable in the denominator. So I'm going to make this look nice. I have a square root of 1 over the square root of 3x. Now, since this is just a square root, I can do the exact same thing. Multiply by root 3x over root 3x. Up top, I get the square root of 3x. On bottom, I get, well, that'd be the square root of 9x squared, which would just be 3x. So no root on the bottom, done. Nothing you can do. Now, we have the square root of x. You can't do anything more with that, all right? It doesn't break down. So, on number 6, this is the last easy one, if you want me to call them that. I'm going to put them all under a big root here, a big square root. Sorry, I changed that x to an n, or n to an x, didn't I? So 5n to the third. Either way, they go away. So this is the square root of 2 over the square root of 5, which means I have to multiply by root 5 over itself. I get the square root of 10 over 5. That's the exact same problem we've done before. I know it. So now, getting down here into number 7. Let me go ahead and take this away. All right, let me do a few of these. So here, I'm going to go ahead and turn into one big cube root. So negative 2b, or not 2b, that is the question. And then 5b on the bottom. The b's go away. So I'm left with the cube root, so it still should be a 3 there, cube root of negative 2 over cube root of 5. Now, I can't just multiply by the cube root of 5 over itself. Here, I'll show you what happens if we do. Then I end up with the cube root of 25. Does that work? No. The reason it doesn't work is you can't take the cube root of 25. So what you have to do is change it up a little bit. All right. Now, 5 to the third is 125. Can I take the cube root of 125? You sure as I can. You get 5. So I want this to turn into the cube root of 125. Well, in order to make that, we'd have to multiply 5 by 25. So I'm going to put a cube on top, and a cube root on top, and a cube root on bottom. All right, so cube root of 5 times cube root of 25 gives me that, which is good. Up top, I would have the cube root of negative 50, which is still fine for right now. Now, on bottom, the cube root of 125 is still 5. Now, up top, I'm going to leave this as the cube root of negative 50. You could also have this as your answer. Take a negative 1 out. That would also be okay. I'm happy with either one of those, as you can probably see in the answers. All right, now, number 8. Just from here on out, I don't think I have to worry about doing this. They go away, all right, just like they did over here and a couple other times in this assignment alone. So we end up with the third root of 8 over the third root of 50. So I'm going to go ahead and just rewrite that. No, I'm not. What I'm going to do is I'm going to be slick. I'm going to be slick here, guys. What's the third root of 8? It is... No, I'm not going to be slick. I'm going to leave it as the third root of 8 right now. Down and bottom, this is the third root of 50. Now, what are they both divisible by? They're both divisible by 2. So then this is equal to the third root of 4 over the third root of 25. And I'm happy about this because now we're dealing with the same issue here. We're still using the same fact. I can't take the third root of 25, but I can take the third root of 125. So I need to multiply by the third root of 5 over the third root of 5. What this does is up top, doesn't really matter, but it gives me the third root of 20. On bottom, it gives me the third root of 125. All right, because 25 times 5 is 125. So now I can simplify this on the bottom. The third root of 125 is 5. I don't have a root in the denominator anymore, which is what I wanted. Up top, though, that's going to stay the third root of 20 because it doesn't break down any further than that. Now, I'm going to try and do one more problem, and it's going to be kind of wild, so bear with me. Stay with me on this. Now, 10 will be a problem that you're going to do on your own. I'm going to take care of number 9. Now, it will have a negative in its answer, and we're still doing the same fact family, if you want to call it that, because I still have the third root of 5. Can I take the third root of 5? Absolutely not. But what you can do, and since I can't simplify anymore, just go ahead and start rationalizing it. We're taking the third root, so we need to multiply by something of the third root. Now, I also have a variable down here. So, with 5, I have 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. So that's what we're looking for right here. We're trying to take the third root of 125. What would you multiply 5 by to get 125? You'd multiply by 25. So that's what we have to multiply by. Now, we have a variable though. Can I take the third root of r squared? No. But you can take the third root of r to the third. That'll just be r. And that's what we want. So with a variable down here, we have to multiply by something that's going to give us r to the third. Now, if I have r squared, what do you need to multiply by to get r to the third? Just another r. So, finding this is the most important part. Because now, up top, there's still a negative. Not really worried about it, though. I have the third root of 25r, which is all well and good. The denominator, though, I have the third root of, now, 5 times 25 is 125, which is great. R squared times r is r to the third. That's also great. We can take the cube root of that. So let me change my color here. And this is what I end up with. There's a negative sign out front. Ooh. The top stays the same. The third root, negative third root of 25r. the bottom. What is the third root of 125? It's 5. What is the third root of r to the third? R. And that's that. Okay. You can handle 10 on your own, I believe. Let me check this real quick and see what we have down here. We got some nasty stuff with 2 variables. All right. Next video, I'll do those.